Assalamualaikum warahmatullahi wabarakatuh and greetings. Today I would like to present about our project titled Design of a Ground Segment for In-Situ Monitoring using Nano-Satellites. This project had been done by Syaril Amir bin Muhammad and Muhammad Hafid bin Ma'ruf. Introduction. First is about In-Situ Monitoring System. The meaning of in-situ monitoring describes the observation or measurement of events in its surrounding environment. It uses sensor nodes to collect data of the surrounding environment or variables where it exists. Then it's about a nano-satellite. Nowadays, nano-satellite is popular to be used for in-situ monitoring system. In this project, we had chosen CubeSat as the nano-satellite. CubeSat is small in size, low cost, and had a short development time. The form factor is used to wirelessly relay sensor node data to ground station. There are two separate segments. First is a ground segment and second is space segment. Ground segment is a system that consists of all ground-based control components of a spacecraft system. Enable control of a spacecraft and distribution of payload data and telemetry among interested parties on the ground. The space segment is a place where the satellite used to relay the data from. Objectives. The objectives of this project are to design the ground segment based on nano-satellites for in-situ monitoring. This will need components like sensor nodes in remote locations that require various additional subsystems for operation at limited space or environment in terms of communications and power, and to obtain the analysis result of the in-situ monitoring system simulation reference from the parameter calculation. Methodology. First is the minimum revisit time. The minimum revisit time that used in this research is only for 1 day. Next will be the orbit altitude. The altitude used 600 km and 950 km. The scenario design. The simulation tool that we are use System Toolkit or STK. The scenario is created to obtain access duration and revisit time. There are two scenarios that we use in obtaining the result. First, the altitude in 600 km with maximum revisit time is 1 day, and the second is altitude 950 km with maximum revisit time is also for 1 day. This will be the example of interface for the System Toolkit Simulations tool software. This is the target area location. The parameter that we are use satellite sensor cone angle is 45 degrees. Orbital inclination is 89 degrees. The location are China, Nigeria, Indonesia, United Arab, Australia, North Korea, USA, United Kingdom, USA, Kazakhstan, and also Peru. Result. First is the sensor node access duration. There are two formula that we use. First, we must obtain the orbit period, and the orbit period value will be used to calculate the access duration by using the formula access duration. Then will be the sensor node for the revisit time. In order to find it, we must use the formula to calculate the maximum revisit time. Next is the uplink and downlink analysis. There are four formula that we must use in order to find the maximum range of the uplink. First is the formula for the noise power density. Second will be the bit energy formula. Then the power received. And lastly, the free space loss.
Okay, so in the STK software, we can see that the satellite has the altitude of 600 kilometer by using the orbit wizard. So we can see the altitude is 600 kilometer and the inclination degree of 89. Okay, so to see the access time, we must select the transmitter on the satellite. So we select it and right click. By clicking the access, you can see that all the areas that we need to see. So first we need to select all the areas and then compute it to see the access time report. So the report, you can see it show that the duration of the access time for the selected target area. So through this simulation, we need to see the maximum revisit time. So to see the maximum visit time, we need to select the transmitter and use the access to object to find the get summary report. To see the get summary report, we need to select all the area that we need to see. So through this report, we can see that the maximum visit time for this scenario is 37,905 a second, which is less than 86,400 seconds, which satisfy the theoretical approximation for this report. So next we need to see the uplink and downlink analysis. So first we need to choose which one is the transmitter and which one is the receiver. So for the uplink case, the ground station is the transmitter and the satellite is the receiver. To see the uplink analysis, we need to choose the access tools and select the satellite receiver to compute the report. After that, we can see the report by selecting the bit error rate, link budget bit error rate report. The report shown that the communication link is stable because the bit error rate is less than 1 times 10 to the power of 96, which is acceptable for the communication link. So for the downlink case, the step to obtain the result is the same as the before, the uplink analysis. So the result is shown in this report. The report shown that the downlink link is also have stable communication.
Conclusion. Based on the parameters that had been calculated, we had successfully simulated the in-situ monitoring system by using a simulation tool known as System Toolkit (STK). We also had learned on how to use the System Toolkit simulation software as we done the simulation in order to obtain the result. As we are using two different scenarios in this research, we had managed to obtain both access duration and revisit time for each of the scenario.